Good morning, ladies and gentlemen, and I'd like to welcome also all the participants. It's a pleasure to be here today as part of the Eurovent team. Let me just start by saying how filtration has become a common denominator in most of the activities or the indoors we find ourselves in. In fact, research has suggested that out of all the time spent indoors, 87 to 90% is spent indoors. Before we take that conclusion home, let's just investigate first how much of that time is distributed on the sort of indoor environments, whether it's a bit of airports, as we travel a lot sometimes, or work, home, shopping mall, restaurants, traveling, factories, or possibly a car. All these sources, we spend our time around 90%. And therefore, we need to consider that we can be infected of any of these indoor spaces. So filtration is, in fact, a separation process, and the essence of it is particle capture. So we would like to do two actions to render a particle captured or filtered. One is to separate it from the airstream, and the second one is to retain it within the lifetime of the filter time. I would like to set or gauge our eye, human eye, in terms of size perception by looking at its hair. So if I split, as you can see, the slide according to its ratio in terms of microns, so you get 140 micron and 250 micron on the x-axis. This is your human hair to scale, and then this is how a 10 micron would look like, which you cannot see with a human eye, and then 1 micron. Now I expand the 1 micron on the next slide, and you can see how is the coronavirus SARS-2 is in terms of size, how would it compare to a 1 micron? So it is a difficult or a sort of challenging particle to capture if it's traveling on its own. And this is just showing an illustration. What would a virus look like in terms of capture when we look at a absolute filter or HEPA or ULPA filters? So we seem to be emitting a lot of particles and a lot of pollutants, whether it's physical, chemical, bioaerosols from different sources like car emissions, fuel consumptions, indoor pollutants, chemicals from factories, particulate matter, for example. It's not only dust, it can be pollen, it can be indoor mold spores. And what I want to highlight here is a couple of things. One is our air quality is a function of our outdoor air quality. So if you look at the picture on the right, how does the outdoor air stays fresh? Basically, you've got a sink, and we pollute so much in that sink, but this is the same sink we have to bring outdoor air to bring it to the air filtration system through our HVAC systems. So we need to look at controlled ventilation strategies, not just go crazy with ventilation, because we might be adjusting or increasing the relative humidity. The heat load might alter, and the number of pollutants. This is a filtration sensitive technique, because we have to look at what kind of filtration we're bringing to bear by introducing a lot of outdoor air, and how pollutant is that outdoor air. Now, indoors can also contribute to the bad air quality or the poor air quality. It can be facilities, people, tools, fluids, even manufactured products. Outdoor air can have a wide spectrum of pollutants, whether it's fly ash, dust, even our human skin sometimes are found in filters, pollen of different sorts. Particle characteristics also are key, because not only particle size, particle size distribution. It's also particle shape and concentration that we need to consider when we making appropriate air filtration selection. Viruses are of a particular interest because they're infectious in terms of nature. They are smaller than bacteria. They come also in various shapes and sizes. They can display life or non-life characteristics. Really depends on the situation they find themselves in. They range in terms of size. They range between 20 micron to 20 nano to 400 nano, with an exception of the Pandora virus, which is about 1 micron. And again, this is a comparison between the Pandora virus and the SARS-2. Now, we need to quantify, before we jump into filter selection, we need to quantify what we are up against. And the beautiful tool of aerosol monitoring gives us that, because not just we can eyeball a sandstorm or a clear sky and say this is clear. We need to quantify this in terms of dust concentration, for example. What would that mean in terms of PM10? And what would PM10 concentration mean of a sandstorm on the spectrum of a size distribution? So would it be 60%? Would it be 50%? What is PM1? And how we can confront it? We feed that excellent information to our filtration experts, and filtration experts will be able to tell us when would the filter clog, or what is the lifetime, how would we expect it to perform, etc. So in order to be also fair to filter experts or filter manufacturers, we need to give them appropriate information in order to position them to give us as close as possible a filter performance that can abide by the test report that they are providing. Believe it or not, filtration mistakes and failures are expensive, and whether we agree or not, we pollute our environment quite a bit, and then now the pollutants are out there. We have to bring them indoors, and then if we don't do our filtration homework, we find ourselves in this situation. And these pictures that you're seeing, in my judgment, is a living testimony of how we put air filtration on the back burner, how we really have not invested in air filtration, and we have not invested in the human occupants. It's also important to realize these pictures tells us whether it's filter delamination or failure or deformation, that we have not really invested on what is air quality, what does it weigh in terms of the overall equation of our building physics. We have not really also abided by the maintenance programs we've agreed upon earlier, but yet today we stand and demand the best indoor air quality so that we are protected and we can stand firm against COVID-19. COVID-19 certainly is coming here to stay if these practices are not going to be altered. I really suggest we need to abide by new mindsets and new regulations that look different and abide by different and innovative guides to match the challenges ahead. The question before us is simple. Where do we want our dust to land? Where do we want our contaminants to land? This is a very simple fan coil unit that I have access to, and a simple upgrade of the filter. You can see that in the case of a very low efficiency filter, your coil has participated in the filtration action, and eventually contaminants settled on the coil, on the diffuser, and of course, subsequently on our respiratory system. If we enhance filtration, we can see that the color of the contaminants is now, instead of the diffuser, it's on the filter, and we have a much cleaner coil and diffuser. So this is the question: where do we want the contaminants to land? If our HVAC system are treated as such, whether as storage or left abandoned for years without maintenance, I think to transpire our desire to enhance indoor air quality will only exist in our imagination. It will never come true if we have gaps in filters, if we leave coils and treat our air handling unit the way you can see in the pictures. But I also want to see it's not only it's not the fault of maintenance teams, it's really how we treat them and therefore how they treat us. So we really need to invest in maintenance teams and equip them with the tools and the conditions to better perform. No wonder duct cleaning and coil washing techniques have become very famous and very common because they need to be called upon to restore the HVAC system to the design point so that we can expect better thermal comfort, air quality, and eventually our well-being is protected. As you can see now, the duct is full of dust, which is supposed to be done as a preventive measure on the filter, and the coil now is participating in the filtration action, which is really not acceptable. Eventually, you have to also wash the coil, disinfect, and remove the dust so that your coil can perform the expected heat transfer and the heat transfer mechanism is restored. The school of thought that we need to maybe entertain or change, I start asking myself every day, before we agree on defining better indoor air quality, let's first define what are the parameters of air quality. What is it that we need to tweak, change, and alter so that air quality is agreed upon? What are we on the same page, speaking the same language? How fresh is our indoor air? We pollute quite a bit and we have to filter quite a bit. Today, the name of the game is the air quality monitoring devices, because they can reveal the physical and the chemical characterization of outdoor and actually indoor, and therefore pave the way for appropriate air filtration selection. We gotta look at preventive measures. We gotta think preventive. We cannot allow our indoor air quality to degrade, our filter efficiency to be deficient, and then we jump to do something about it. We gotta think preventive and make sure that we abiding by the homework, the filtration homework, which now in any event we need to enhance. Again, I stress on that point. We pollute so much in a sink that we may think it's infinite, but it's not. It's a finite, and that atmosphere, the sink called atmosphere, is the same sink we stick our straw to inhale air and bring it to our respiratory system. Again, what kind of filtration we bring to bear, what sort of filtration selection we need to make, and how appropriate are very important questions. Enhancing indoor air quality, technologically speaking, I believe we have what it takes to confront COVID-19 and coming outbreaks, but we have got to redo the math on what we're doing. We cannot just simply go ahead with tricks and filtration mistakes. We need technologies, we need to invest on maintenance measures and abide by it. We need efficient filtration, appropriate filtration selection, and we need filtration strategies, not shortcuts. If we position our mindset for a shortcut so that we can save on cost, I believe we're not positioning ourselves to enhance indoor air quality. And all what you were talking about in terms of improving indoor air quality will only exist in our imagination, and we'll never see a substantial increase in our improvement in indoor air quality. That takes me to the couple other points. We need to look at testing standards that are relevant to the Middle Eastern environment so that we can verify filter performance considering the climate conditions in terms of chemical, physical, and bioaerosols. It's not only filtration, it's an integrated approach between filtration, HVAC, how we also provide ventilation, and what sort of approach we bring to the platform. I want to leave you with this. Please optimize, do not compromise your filtration. Treat your HVAC system as precious as possible. Treat every single human occupant as this premature baby who's basically got no say but relies totally on us as a total basically experts to select his or her filters so that the air quality is optimized. I want to end at that point and call upon Marcus. Marcus?
Yes, thank you very much, Iyad. Very interesting presentation. How much do you think is indoor air quality also relevant in order to strengthen the immune response towards COVID-19?
Well, I think we need to. There are a couple of points on your question. One is we need to understand what sort of filtration we have. If we rely on single 10 mm filters installed in our residential homes, I don't think we're going to get so far. I think there is a homework to be done on the filtration part, but there's also homework to be done on the HVAC systems. It depends on what we have in terms of particle size distribution, what bioaerosols we have. We also need to understand that there are byproducts, so we could have X product with Y product that can give a Z product. So it's not that simple to say, yes, if we improve filtration by that much and we increase ventilation and keep relative humidity within a certain range, that we're going to get so far. It's an integrative approach. I think we need to be very careful. This is why I call upon filtration experts to play a much bigger role in making filtration selection.